All right, so quadratic equations are one type of problem you should be familiar with, and if you look on the algebra review worksheet, I think number 9 is a quadratic that you're supposed to solve that will give you some practice with that. The second type of problem we're going to look at today also requires a bit more work than your traditional problem you might be familiar with. And again, let me give you some given information, let me give you a starting equation, and let's go from there. Let's say we're given that lowercase f, which stands for frictional force, is 4.7. The units are kilogram meters per second squared. Capital F, which is some other kind of force that's pulling on this object, is 24.5 kilogram meters per second squared. And M1, the mass of this object, is 5.0 kilograms. So that's our known information. But this time there are two things that we don't know. Right, first problem that we've encountered like that, where there are two unknowns. We don't know capital T, which stands for tension, and we don't know lowercase a, which stands for acceleration. So two unknowns. Starting equation is T minus little f minus big F is equal to M1A. So what do you do when you have two different unknowns? That's the question. Well, we could solve the equation for one of the two unknowns. We could solve for T, add the f's to the other side, get M1A plus little f plus big F. Well, where do we go from there? And that doesn't help us a whole lot because we don't know what A is either, so we can't go plugging in the numbers just yet. And you might say, well, it seems like I learned something like that in Algebra 2, where if you take all that and you plug it back in, the equation for that, will that work if I plug that back in for T? Well, let's try it out and see what we get. If T is equal to that, then we should be able to put it in there. So let's plug in M1A plus little f plus big F. Let's plug it in for T in the top equation. And then we have that minus little f minus big F is equal to M1A. Does that help us? Well, on the left-hand side, it looks like our f's are going to all cancel out because we have little f minus little f and big F minus big F. And that leaves us with M1A is equal to M1A. Well, that's true. M1A does equal to M1A. In fact, that says 1 is equal to 1. All very true, but completely useless. Doesn't help me at all in figuring out the value for A or for T. All right, well, that didn't work, so let's get rid of that. No point in keeping it there. What do you do when you have two unknowns? Again, this is something that you spend some time working with, so it's not something that you've never seen before. But to be truthful, I didn't give you all the information that you need to solve the problem. Because one of the things you should remember from algebra is that if you have two unknowns, you need how many equations? You need two. The number of equations has to match the number of unknowns. If there's just one thing you don't know, then one equation is fine. But if you have two unknowns, you better have two equations that involve those unknowns. If you had three unknowns, you need three equations, and so on and so forth. So you can't solve this problem as it is. I need to give you more information. I need to give you a second equation. So let's call the equation you already have equation number 1. I need to give you equation number 2. And equation number 2 says that M2G minus T is equal to M2A. Notice the second equation has the same two unknowns, T and A, in it as the first equation. Now it also has M2 and G in it, so you'll need to know those values as well. You need to know that M2 is equal to 3 kilograms, and you need to know that G is equal to 9.8 meters per second squared. And now we can solve the problem. But how do we do it? When you may remember calling this a system of equations. When you're solving a system of linear equations, there are a couple different approaches you can take. One method is to do what we started to do before, and that is to solve one of the equations for one of the unknowns, and then substitute it in the other equation. That method works fine. In other words, in equation 1, remember we had solved for t, and we got t is equal to m1a plus little f plus big F. And that works fine as long as you take that value and you substitute it into the other equation. You can't substitute it back into the same equation. You've got to substitute it back into the other equation. If you do that, equation 2 then becomes m2g minus t, where t is m1a plus little f plus big F, equals m2a. Notice in doing that we completely got rid of the t's. We're now down to one unknown, and we can solve one equation with one unknown. Now the unknown we're trying to find, a, is showing up two different places. It's showing up here and over here. So before we can solve for it, we've got to get them on the same side of the equation. So let's get rid of the parentheses there. Let's distribute the minus sign. m2g minus m1a minus little f minus big F equals m2a. And let's get our a's over on the right side of the equation. So I'm going to add m1a to both sides. So on the left I have m2g minus little f minus big F. On the right I have m2a plus m1a. And the reason for wanting to group them on the same side is so I can factor out my unknown, factor out the a. So a times the quantity m2 plus m1 is equal to m2g minus little f minus big F. And then finally I can divide both sides by the m2 plus m1 and get a is equal to m2g minus little f minus big F all over m2 plus m1. And now I'm ready to plug in numbers because the only thing I don't know there is a, and that's what it's solved for. That's one way of getting one of the unknowns. But let me show you a way that I think is a little bit easier than that, a little bit less work. You may remember from Algebra 2 that if you had something that looked like this, remember in math class they always like x's and y's. They don't like anything else in that. So maybe you have 3x minus 2y is equal to 4, and maybe the other equation is x plus 5y equals minus 3. Two ways you could solve this system. You can do what we just did, solve one of the equations for one of the unknowns, substitute it back in the other equation. Or, remember, the other method was to try to add the two equations together in such a way that one of the unknowns would cancel out. Now, in this problem, if I just add them together, the x's aren't going to cancel, neither are the y's. But I look at it and I realize, if I multiply that second equation by a minus 3, if I were to multiply the second equation by a minus 3, the second equation would become minus 3x minus 15y is equal to positive 9. And now if I add the first equation to that equation, when I add them together, the x's are going to cancel. Because I have positive 3x and minus 3x. And then if I add the y's, I'd get minus 17y is equal to 4 plus 9, which is 13. And then divide both sides by negative 17, I have my answer. Right? So that's the other way you can solve these things. Try to add the two equations together and hope that something cancels out. Well, let's go back to our original two unknowns. Original two equations, rather. Here they are. And just looking at those two equations, I realize that, if I just add those two together, I have a positive t in equation 1, I have a negative t in equation 2. The t's are going to disappear. So when I do that, from the second equation, I'm going to get m2g. The t's cancel. From the first equation, I'm going to get minus little f minus big F equals, on the right-hand side, I'm left with m1a plus m2a. And that took us in one step. In one quick step, it took us the whole way down to here from doing it the other way. So it's a little bit quicker to arrive at the answer. Either way is fine, though. And either way will eventually get you to the point where A is equal to all this stuff. And let's plug in the numbers. A is equal to M2G. M2 is 3 kilograms. G was 9.8 meters per second squared. Minus little f. Little f was 4.7 kilogram meters per second squared. Minus big F. Big F was 24.5 kilogram meters per second squared. All divided by M2 plus M1. M2 was 3 kilograms. M1 was 5 kilograms. All right, so plug in the numbers. On the numerator, we have 3 times 9.8 minus 4.7 minus 24.5. Numerator comes out to be 0.2 when you do the math. The units are kilogram meters per second squared. Divided by the denominator, 5 plus 3 is just 8 kilograms. So I'm left with 0.2 divided by 8. 0.2 divided by 8 is 0.025. And the units, the kilograms are going to cancel. I'm left with meters per second squared. All right, so A is equal to 0.025 meters per second squared. Am I done? No, I'm not finished, because remember there were 2 things that I didn't know. I didn't know A, and I didn't know T. So I still have to get the second unknown. I have to get the value for T, which stands for tension. And if you remember, I don't have to go through the whole process over again. All I've got to do is take this value for A and plug it back into either of these 2 equations and solve for the other unknown. In fact, I'm going to do that right here where I already have equation 1 solved for T. That says that T is equal to M1A plus little f plus big F. So since it's already solved for T, I might as well use it. T is equal to M1. M1 was 5 kilograms times A. A we just figured out was 0.025 meters per second squared. Plus little f. Little f was 4.7 kilogram meters per second squared. Plus big F. Big F was 24.5 kilogram meters per second squared. And if I do the math there, 5 times 0.025 plus 4.7 plus 24.5. Left with T is 29.3. The units are kilogram meters per second squared. And now I'm finished. I have my 2 solutions. Now again, that takes some work. To solve a system of equations, to solve the equations simultaneously, you either add the 2 together to get something to cancel out, or you solve one of the equations for the one unknown, you plug it in the other equation, or there are actually other ways you can do it with matrices and determinants, but they all require some work. Again, if you have a graphics calculator, that very same application I showed you a minute ago that will solve polynomials will also solve simultaneous equations. So let's take a quick look at that for those of you that have it. And again, this is something, but I still want to see the work that you know how to do it the long way. So again, I'm going to go into my apps, and I'm going to open the same app that I did before, that one that's called PolySimult 2. But this time I'm going to tell it that I want to use the simultaneous equation solver instead of the polynomial root finder. So that's choice 2 in the menu. Press enter. And the first thing it asks me for is how many equations do I have and how many unknowns do I have? Well, in this problem there were 2 equations, there were 2 unknowns. And that's how everything's set up. The rest of everything should be fine. I'm going to hit next. And let me just, I don't think it'll let me clear this out first. So let's look at what they're asking us for. It says system matrix 2 times 3. It's a 2 by 3 matrix, and it wants us to enter the coefficients for that matrix. So let's set things up so you can see how this works. it wants us to write the equations in the following form. I'll go to a blank screen here. It wants us to write them in the form a times x1 plus b times x2 equals c. Let me call this a1 and b1. And then the second equation, it wants us to write it in the form a2 x1 plus b2 x2 equals, we'll call this in c2. In other words, both equations have to be written with the unknowns on one side of the equation, unknowns are x1 and x2, and the constant on the other side of the equation. And they have to be written in the same order. So if you remember, my first equation was t minus little f minus big F is equal to m1a. Let me just write that right here. T minus little f minus big F is equal to m1a. My two unknowns are t and a. I got to get them on the same side of the equation. So I'm going to write it as t minus m1a. And then I want the constants on the other side. So t minus m1a equals little f plus big F. And then my second equation, if you remember, was m2g minus t equals m2a. I've got to write it with the unknowns in the very same order as I have in the first equation. So I have to write the t term first, that's minus t. Then I have to write the a term next, so that would be minus m2a. And then I have to take the constants over to the other side. So it would become minus m2g. So minus t minus m2a equals minus m2g. Or I could multiply through by a -1 and make all those positive. Now, once I have it written in that format, it's going to want me in the calculator to enter the coefficients of each of these terms. So first it's going to want the coefficient of the t in the first equation. That's just 1. Then it's going to want the coefficient of the a in that equation. And then it's going to want the constants in that equation. And then it's going to go through the same thing in the second equation. Coefficient of t, coefficient of a, constants. All right, so let's go ahead and enter those in the calculator and see what we get. Let me kind of move this to the side so we can see both at the same time. The 1, 1 there is the coefficient of t in the first equation. That's simply 1. So I'm going to type in 1, press enter. And now it's asking for 1, 2. That's the second thing in the first equation. That's minus m1. And minus m1 would be minus 5 kilograms, so I put in minus 5. And what it's asking for next is the constant. And the constant was little f plus big F. Little f was 4.7, so I put that in. Plus big F was 24.5. Put that in. Press enter. Now if I look in the first row of the matrix, I have the coefficient of t, the coefficient of a, and my constants. And now I'm ready for the second equation. In the second equation, the coefficient of t once again was 1. Coefficient of a this time was m2. My second mass was 3 kilograms, so I'll type in 3. And then finally, once again, the constant was m2 times g, which would be 3 times 9.8. And press enter. Once I put in all the proper coefficients, I'm ready to solve. So I'll press the button here below, solve. And notice it spits out the two solutions. It says that x1, that was my first variable, which was t, is 29.3. And x2, the second variable, which is a, is 0.025. And notice those are the very same two solutions that we got doing it the long way. We have a is 0.025, a is 0.025, and t is 29.3. Now, I will be the first to admit that in a problem like this one, it may have been quicker just to do what we did than to set up everything properly there in the calculator. But that is an alternative way of doing it, and it's a way to quickly check your work. Problem number 10 in the Algebra Review worksheet will give you some practice solving simultaneous equations. So at this point, you should be able to solve any of the problems in that algebra review worksheet. And in fact, at this point, you have seen algebra as nasty as it's ever going to get in this course. There is no algebraic technique that we are going to use that's any more challenging than what you've seen already. This is as tough as it gets. So if you're able to handle the math for this part, you should be able to handle anything for the course. All right, so good luck with solving those problems. Just make sure you ask questions about anything that you're not understanding.